Okay, so in this video, we're going to learn how to convert the decimal number with the decimal point into the 32-bit single precision floating point representations. Okay, so first of all, before we do that, to put into 32-bit single precision floating point, we need to convert this decimal into the binary number. So after we convert the binary numbers, then we need to change the binary number into this format. So if 75.625, we convert it into the binary number, we will get these values. Then what we need to do is we need to bring the decimal point into the into here. Okay, so we just write it out 1001 011 dot 101, our binary numbers. Okay, so we need to bring this thing first 1 time, 2 time, 3, 4, 5, and 6. So it should be here. Then we bring them 6 times, so it's equal to 1.001011 multiplied by 2 power of 6, because we bring them 6 times, right? And this is the binary number, so that's why it's 2, not 10, right? If we in a decimal we bring them 6 times, we 10 power of 6. But this is in binary, so it's 2 power of 6. Okay, so we already converted it into this format, if you are able to see it. So since it's 75.625 is a positive number, right? So it's equals to -1. The sign number should be 0 because it's a positive number. So -1, so the sign bit is 0, right? If power 0, then it becomes 1, right? If it's a -1, then if it's 1 power 1, it becomes -1 here, right? So now it's positive number, so that's why it's 0. So power of 0, so it becomes 1. Then multiply with 1 plus f, the floating point. So the floating point here is equals to all this number, the one in here. Hold on. So it's equals to 1 plus 0.00101101. So this is the floating point. Then multiply with 2 power of e minus 127. Okay, so e minus 127 should be equal to 6 if according to this one, right? So this is the same. So the e will be equals to 127 plus 6 equals to 133. Okay, so you have your e already, right? The e here. So the e need to convert it to binary number also. So this will be the values to put into the e. Okay, so by this way you're already able to fill out the thing. So 8-bit values for e, then the sign bit should be 0 because it's a positive number, right? Then the last one is the fractions. Okay, this will be the fraction number. So this is the fraction number, you should bring it in. So it should be 00101 1101. Then the rest you just fill up with 0 until it reach 23 bits. So now here is how many bit already? 4, 6, 8, 9. So 9 bit already. So you need to add in 14 bits already. So to fill it up until it reach 23 bits. So the rest is filled up all with 0. Then you complete the conversions. Okay. So someone may ask why we need to minus -127 in this exponent, right? So it is because to leave the space for you to represent the small number, something like let's say you want to represent 0.625, right? So let's say we do this thing. So if you convert it to a binary, it should be equal to 0.101, right? 0.101 in binary, right? So do the same thing. We want to convert it into this form. Okay, so we want to convert it into this form, so we need to bring this number 1 bit to here. So it's also equals to 1.01 multiplied by 2 power of -1, since now you are moving it to the right hand side, right? So it should be -1, same as what you did in decimal, just the thing you change to 2 instead of 10. So it's the same. So this is a positive number, so your sign should be 0. then the exponent is this thing, right? So e minus 127 equals to -1 here. So now is e equals to 126, right? So your 126, just convert it and put it into this area here, right? Okay, so your 126 is equal to this number here. So you just need to fill this number into the exponent part, right? So your exponent should be 1, 1, 1, 1, 1, 1, 0, right? Then the rest is the left, the one you left is the fraction. So the fraction is this one, right? So it's a 0, 1. You just fill it up here, then fill the rest with 0 until you reach the 23 bits. Okay, so this is how you do the, till this is 23 bits, then you stop. Okay, so this is how you convert the decimal number into single precision's floating points. So for the only difference is for you have a number, bigger number, the exponent should be in terms of positive. If you have small number, the exponent should be in terms of negative. So the step is to convert a number, decimal, into the binary. Then in the binary forms, you need to convert it into this format, which is 1 point something, multiply with the 2 power of something, right? Then you only need to convert the e, and you fill up the fractions into the 22 bits here. Okay, so I think this is all we want to show on conversion of decimal to 32-bit single precision floating point.